Hi everyone, this is MK, and here is another LeetCode Daily challenge. Today we have a quote from the Shawshank Redemption. I love this line where Andy says, "Hope is a good thing, maybe the best of things, and no good thing ever dies." Okay, today's problem is an easy problem. I will solve it with two different approaches. First, a brute force approach, and then a two-pointer approach. Let's go and read the problem. The problem is about the intersection of two arrays. So we are given two integer arrays, num1 and num2, and we should return an array of their intersection. The only catch is that the elements in the result should be unique, and it doesn't matter, we can return it in any order. It doesn't need to be in sorted order, in increasing order or decreasing order. So this is the first example. We have 1 2 2 1. So as you can see, input is not sorted, and num2 is 2 and 2, and the intersection is number 2, only once, not twice. Here we have 495. We have 9 4 9 8 4, and again 9 and 4, only one 9 is the intersection, and we return it. So how do we solve this problem with a brute force approach? A brute force approach is trying all possible ways to find the answer to a question. Like, what I mean, let's go and take a look at the example. So imagine you want to find the intersection between A and B. Okay, so you have A0, A1, and A2, and so on, and you have B0, B1, B2, and so on. So the brute force approach is you take A0 and you check it with every element in B. You ask, are you A0? Are you A0? Are you A0? And so on until the last element. This checking of A0 with every other element in B is a brute force approach. Okay? And we do the same for A1, and we do the same for A2. We are not being smart. We are not using any data structures. We are not using any specific algorithms. Just a very simple linear search algorithm. Linear search is this. Are you A0? Are you A0? Are you A0? And so on. Checking A0 with all of the members of B is a linear search. Okay? And if at some point the answer is yes, if A0 is equal to some BI, we add that to C, which is a set C. Okay, A0. Remember, the answer should have unique elements, and set lets us have unique elements. The most important application of the set data structure is that it keeps the elements that are unique, like only unique elements are in set. There's no repetition in set. That's what I want to say. Okay. All right, let's go and write the code for the first solution, and then we are going to discuss the second solution. So for the first solution, we need a set C, and then I'm going to call input A and B. And then we are going to take every element of A. So for int x of A, we are going to take every element of B. So for int y of B, if x is equal to y, that means we have an element that is in both of the arrays. So c.insert x. And we do break because we just found out that C exists in B. Okay? And that's it. This gives us the intersection, and we add all of them to C. We just need to add this set in a vector because the answer is a vector. So we define a vector int result, and we iterate over all of the members of C, and we add them to result. Okay. And we run 2 green flags. Okay. And submit. Okay, this was the first solution. Let's go and see the second solution. The second solution involves sorting. And the running time is gonna be better because the brute force approach was very slow. I'm gonna write about the running time and the space complexity in the comments or the show notes. Yeah. So the second solution, we sort A and then we sort B. Okay. And now we know that A is sorted. So let's say we have 4, 9, 17, 22, something like that. Okay. And then we have here 2, 4, 7, 10, something like that. What we do, we need 2 pointers, one that is pointing to the A and one that is pointing to B. We compare the two. Is A0 equal to B0? No, it is not. Right? So A0 in this case is greater than B0. A0 is 4, B0 is 2. So what happens here? If this is I and this is J, in this case, we should increment J. Why? Remember, we are looking for intersection. So we are looking, in this case, A has a 4, B has a 2. So we are asking B, hey B, do you have a 4? And B says no. And the smaller number is guaranteed that is not going to be visited again. So what I mean is that A is not going to visit 2 anymore because any other number that comes after 4 is greater than 2. Sorry, greater than 4. Okay, so because of that, we increment J. So, and if, so this was one of the cases. So if A0, AI, let's say, is greater than BI, in this case, we increment I. Because this is the smallest number, the smaller number, and this number is not going to be matched anymore. So this is the one case, this is another case, and the last one is if AI is equal to BI. In this case, we should increment both I and J, sorry, BJ, sorry. So in this case, we should increment both of them because we found a match, I++, J++. But before we increment them, we should add the answer to a set C. So here we say C.add AI and then I++, J++. So remember, we can remember the condition that the output should be unique. The elements of the output should be unique. So we can solve that problem with the same set data structure, or each time we are adding a number to C, we can compare AI with the last number that was added to C. So in this case, for example, let's say you have let's say here, let's say you have 3, 3, 4, 7, and we have 3, 3, 5, 9. Okay, and here is C. So we compare 3 with 3, that is a match. So we add them to C. So that is gonna, 3 is gonna be added to C, which is the result. Then we increment I, we increment J. Now we compare the two again. 3 is equal to 3. We want to add 3 to C. But we should check the last number that was added to C. And since 3 is equal to 3, we don't add it. And why can we do that? Because the numbers are in sorted order. And if numbers are equal, they are going to be added consecutively to C. All right? That's why we can just check the last number that was added to C. In this case, we just ignore, we skip basically, and we go to the next one. I just wanted to show you that we compare the last added number to the current match. That's it. Let's go and write the code here. I need to reset this. So A, B. So this time I just need a vector int C, and we just return C at the end. We need 2 indexes. So int I is 0, int J is 0. So while I is less than a.size, while I is valid, and while J is valid, okay, if AI is equal to BJ, what do? We check if C is empty, or C.back, which is the last number that was added to C, is not equal to AI. Okay, we add AI to C, C.push back AI. And here we increment I, we increment J, regardless of the fact that we were able to add it to C or not. We increment I and J. Else, if AI is less than BJ, in this case, we just increment I, and else we just increment J. Okay? And here we just return C. Yeah, let's just run the code. Wrong answer. So 9. Oh, we should sort them. Sorry, we should sort them. Sort A.begin, B.begin. Sorry, A.begin, A.end. Yeah. And B.begin, B.end. Okay. And that's it. We submit. Okay, that's it. I hope you enjoyed this problem. Please do subscribe and follow and subscribe. That's the same. Yeah, or not. I don't know. If you enjoy, and introduce me to your friends. Thank you. Have a good day.